How's it going? Pretty straightforward today. I just want to talk to you guys about how to evaluate function and using a little bit of function notation. So a lot of this is going to be the same as what we have been doing. It's just going to be a little bit different notation. So what if I said f of x is equal to x minus 5? Now we've said before that that's pretty much the same as saying y is equal to x minus 5. You're going to see why we need to use a little bit different notation probably next week, but for right now, you can treat these two things as being exactly the same. If I said this, we want f of 4. What that really means is x is equal to 4. Okay? These are the same thing. What they're saying is plug in x, see what comes out for y. Okay? So nothing has changed here in the math. All we need to know a little bit now is about this new notation we've been talking about, okay? So what does this mean? This means go ahead and plug in 4, okay? So we're going to say f of 4, right? So the function evaluated at 4 is equal to, well, let's plug in 4 for x, and 4 minus 5. So f of 4, that's how this is pronounced, f of 4 is equal to, well, 4 minus 5 is going to be negative 1. Okay? So that's all I really wanted to go over today is pretty much how to plug numbers into this and get used to this. Now, what does this mean? This means that x is 4 and y is negative 1. So that's a point, and we can graph that, and we can do a whole bunch of these, and we can find out what the graph would look like. All right? So what if I told you, I'm going to change up the letters and say, what if I said k of x is equal to x plus 5. And we want to know k of 5. In other words, plug in 5. Okay? Well, we would say then k of 5 is equal to 5 plus 5. Right? Everywhere I've seen x, I'm going to plug in 5. And 5 plus 5 last I checked was 10. Okay, so what are your coordinates? 5, 10. The function evaluated at 5 is 10. All right, what if I said h of n? The function h evaluated at n. Okay, so 3n plus 5. And I want to know what's h of 4. So we're going to take the function h and evaluate it at 4. Notice I wrote lowercase h, always lowercase letters over here. If you're doing uppercase letters, you're really far. You're really far into math, okay? So again, if I am going to plug in 4, everywhere I've seen n, I'm going to replace it with 4. All right, so h of 4 is equal to 3 times 4, which is 12. And 12 plus 5 last I checked was 17. So h of 4 is equal to 17, and so we would say the point is 4, 17. Okay. A couple things. When they write these letters, they'll generally be like almost like italicized. I can't, I'm so bad. I can do it with f a little bit. So it'll be like something like f of x. They'll write it a little fancy to let you know that it's not a variable. Right? This is not h times n, right? This is the function h evaluated at n, okay? So that's right when we start off, people want to not multiply these. You're evaluating the function h of n. Everything should be on this side of the equation, or on this side of the function, okay? All right, we'll do one more, we'll talk about why this is. So what if I said h of t? It's a really common one, height as a function of time. First of all, when you have t's and my plus signs look a lot alike, okay? I write my t's a little bit fancy, put a little on the bottom, okay? Little, I don't know what you want to call it. Okay, so that's going to equal to 4x minus 2, and they want to know h of 2. Okay, so we'll say h of 2 is equal to 4. Let's replace this x with a 2. 4 times 2 is 8. Okay, and we'll say h of 2 is equal to 8 minus 2, which is going to be 6. So again, what did I plug in? I plugged in 2. I got out 6. Okay? All right. Now, why didn't we choose from the get-go? First of all, this notation is a little more confusing. What is going to be useful for is, what if I said this? What if I said I have a system, but I have two of them. I have a system. F of x is equal to 3x plus 2. And I have g of x is equal to x squared minus 1. Now, if you're given two of them together, yeah, it's like what we have in here. It's like a system. But now we can differentiate between the two functions. This is f of x. This is g of x. Okay. So what if they said f of 3, g of 5, and g of -3? Well, now, again, f of 3, now I know they want me to plug it into this one. G of 5, I know they want me to plug into this one. G of -3, I know that they want me to plug into this one. Now, if you notice, this one here, a little bit different of an animal than what we've been dealing with, right? We've been dealing with lines. This is what we're getting at. This is not a line. Okay, so we'll talk about what this means. You can still evaluate it, so we'll go ahead and we'll evaluate it today. But let's start with this one. We want f of 3, so we're going to say f of 3 is equal to 3 times 3 plus 2. So f of 3 times 3 is 9. So f of 3 will be 11. Let's plug in 5 to this one. Say g of 5 is equal to 5 squared minus 1. Now again, we haven't been dealing with exponents. That's actually been one of those things we've been avoiding. This is what we'll be going next. So I just want to give you guys a sneak preview. 5 squared is 25. And 25 minus 1 is 24. Okay, so what can we say? Again, I'm sorry, I'm at 3, 11, 3, 3, 11. 5, 24. Okay, and again, this last one, we want, which function we want to plug it in? This function. Say g of -3 will be this function evaluated at -3. Okay, so g of -3, -3 squared is 9. 9 minus 1 is 8. Okay, so again, all we really want to do is to be able to plug in these functions. We'll talk about what this all means in the future. But again, all I really want you guys to be able to do is plug in functions. So I'll give you guys a few of those to do. None of them will be like this with the squares in them. They'll all be linear stuff, so you guys have no problem. Just get used to the format. Don't be intimidated by it. It's nothing new. It's literally addition, subtraction, multiplication, division. Okay, so give it a try, and I will talk to you guys tomorrow.